Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. Today we'll be continuing with the next series of our Statistics Paper 2 of 2026, and we'll be continuing with questions from 41 to 50. We have previously done almost all the questions of Statistics Paper 2 in the parts of the series. If you haven't watched it yet, you can go to our channel and watch it now. And if you are still facing any doubt, you can comment down below or you can text us on our WhatsApp, and we'll be helping you out in your doubts. And the most important thing that I would like you to know that this series is very important for all the serious ISS aspirants. If you're not serious, then it's okay that if you're not watching. But if you're serious, then PYQs are of utmost importance in this ISS examination. Since you all must be knowing the concept about it, so you should know the seriousness of this topic, this PYQ that we are doing, and we are taking it at a very slow pace. And I am explaining even simple bits of the uh, concepts behind the numericals and the theoretical portion. Even if you feel any doubt, you can ask me freely. Now, moving forward towards our first question of the day, question number 41. So, this is our question number 41 on the screen. I hope that you all can see it. Question number 41 has given us the PDF or PMF because it is the random distribution for all the PIFs. Sorry, all the discrete distribution. This has been given to us. So they have given us random distribution and probability that xi is equals to k has been given to us as 1 upon n. For all k goes from 1 to capital N. Okay, and n belongs to an integer number. Z means integer. Okay. Now, first of all, we have to calculate, this has been given to us. So first of all, we have to calculate the likelihood function. For calculating the likelihood function of this, likelihood function of n, it will be summation over I goes from 1 to n, 1 upon n, which will simply be 1 upon n raised to the power n. Okay, this is the simplest likelihood function. Now we all know that xi lies between 1 and n. This we also can state in ordered statistic that 1 is less than x1 is less than x2 and so on, less than equal to xn, less than equal to capital N. This we can write it like this. From this we can see that x1, the minimum of all the xi's, is always greater than 1 or equal to 1, and xn, the maximum of all the xi's, is less than equal to the value of capital N. So to calculate this, we will transform our likelihood function with an indicator variable. Now our likelihood function will become 1 upon n raised to the power n into indicator function that xn is less than equal to n into indicator function that x1 is greater than equal to 1. Why are we using indicator function? Because if we take random values of n, suppose if we take this as our likelihood function and we say that we are drawing a dice whose maximum number is we are drawing two dice. Now we are calculating the sum. The sum comes out to be 12, but the maximum number a dice can have is 6. So that is why we should consider this xn. Xn is the maximum number and n should always be greater than the maximum of this. And if we are getting 6, if we are getting 12 and the maximum n should be 6, so it should always be greater than 12 or equal to 12. It shouldn't be less than that. That would defy our assumptions of the what do we call, of the n term of the of the numerical that has been asked, or of the estimator. So that is why we take an indicator function in this. It is very important to consider indicator function to establish the lower limit and the upper limit of any function. I hope the concept behind using the indicator function is clear. Now here we'll be using Fisher-Neyman factorization theorem. What does Fisher-Neyman factorization theorem states? That the likelihood function should be a function of GTXN into HX. Now if we consider this, this whole thing is nothing but GTX, and the remaining part is Hx. If you compare these two equations, then we get. Now from here, the sufficient statistics is Tx, and the value that is x is xn. And hence we can say the sufficient statistic of x is xn, which is the maximum of xi. They have asked us the sufficient statistics for parameter n. It is xn. This is your final answer, which is our option number B. I hope the concept behind this is clear. If not, then you can again ask me. I will explain it again. Now moving towards our second question. This is a statement based question. We have been given two statements. First statement gives us that we have been given a density function f theta. So the PDF, which is theta e raised to the power minus theta x. And they have asked us to calculate method of moment and maximum likelihood. So first of all, let us calculate method of moment. Now we all know that the formula for method of moment is expectation of x is equals to x bar. Here this is exponential distribution with parameter theta, and the expectation of this value is 1 upon theta. We all know this is x bar. So the value of theta cap from here is 1 upon x bar. So we have calculated our method of moment estimator. Now if we have to calculate our MLE estimator, so let us consider our MLE estimator. For MLE estimator, first of all, we have to calculate our likelihood function. Likelihood function will be theta raised to the power n e raised to the power minus theta summation xi. Summation over I goes from 1 to n. Now if we take log of this L, this will be n log of theta minus theta summation xi. If we differentiate this log of L with respect to theta, it will be n upon theta minus summation over xi, and we have to keep it equal to 0. By keeping it equal to 0, it will be equal to theta cap is equals to n upon summation xi, and summation xi upon n can be written as x bar, so we can write it as 1 upon x bar as our final answer. So this is the MLE and that is the MOM. Now let us see what the statement gives. I am taking both of them on the same page. First statement says that the estimator of theta with method of moment is x bar. But here we have proved that it is 1 upon x bar. So our statement 1 is wrong. Now both the maximum likelihood estimator and method of moment estimator of theta are same. Yes, if we can see that it is same 1 upon x bar, so our statement 2 is the correct statement. Hence we can say that B is the correct option for this question. That only second statement follows. I hope that it is clear. Now moving forward to another question, which is 43. And this question, we have taken one full series of one full lecture of this kind of question. We have taken it in the YouTube channel. I have uploaded it, as well as in our courses. We have done it in very detail. Just by seeing the question, those who have done the lecture might have answered the question. So let us see what is there in this question. They have given us that xi follows binomial Bernoulli random variable. So if xi follows Bernoulli with parameters 1 and p. So summation xi, which is t, will be following. We know that summation of Bernoulli will follow binomial with parameters n and p. This is the understood statement that we all know. Now we have to find the UMV UE of phi p, which is p1 minus p. Before this, let us calculate the expected value of t, which is the mean of t. Mean of t will be np, variance of t will be np1 minus p, and expectation of t square will be variance of t plus expectation of t whole square, which is np1 minus p plus np whole square. Right? This is the value. Now to calculate the UMV UE of this uniformly minimum variance unbiased estimator. First of all, we have to see whether the estimator is biased or unbiased. To calculate this, first of all, let us calculate the unbiased estimator. So if we are calculating the unbiased estimator of P1 minus P, it should be, let us say, T into n minus T. Expected value of T n minus T we have to calculate. It will be equal to n expected value of T minus expected value of T square, which will be equal to n into expected value of T here is np minus expected value of t square is np1 minus p minus n square p square, right? So by solving this, you will be getting the value as n minus 1 into p minus 1. This will be the final value that you will be getting it by solving. You can solve it on your own. I'm writing the final answer. So here you can take expected value of t n minus t upon n minus 1 equals to p minus 1. As you all can see, the expected value of this is p minus, sorry, 1 minus p. Here also it is 1 minus p 1 minus p. So this is our UMV UE of P1 minus P. And the option that matches this is option number B, which is the correct option for UMV UE. This in detail I have explained you in one of the lectures. If you haven't understood it, you can go back to one of our lectures and there you can find the UMV UE, how to calculate UMV UE, quickest way to calculate UMV UE for these kind of distributions. Now moving towards question number 44. Again statement based question. Now the first statement states that if a sufficient statistics T for theta exists, then MLE will be a function of sufficient statistic T. Statement 1 is the statement of Fisher-Neyman factorization theorem. Okay, statement 1 is Fisher-Neyman factorization theorem, hence it is absolutely true. So statement 1 is true. Now seeing the statement 2, what does it say? That theta cap is the MLE of theta, then theta cap upon 1 plus theta cap is the MLE of theta upon 1 minus theta. So by invariance property, if theta cap, or let us say phi cap. Phi cap is the MLE of phi, then G phi cap is the MLE of G phi, which is the function of phi. We can state this, but there is a twist here. In the denominator, it is plus in this, in the estimator, and of the parameter it is minus. So the sign has changed. So it cannot be the same. Hence we can say that this statement is wrong. Otherwise, MLE follows invariance property, but just because of the sign, we state that this equation is wrong, and hence our option number 1 is only correct, which is A. A is the correct option for this question. Now moving towards question number 45, the best question in which we don't have to do anything. Whenever Cauchy distribution comes, and if they ask us about mean, or if they ask us about the minimum variance bound, MVB estimator, so our only answer will be it does not exist. Option number D. Mean and minimum variance bias estimator always doesn't exist for Cauchy distribution. Why minimum variance and when minimum variance bound distribution do not exist? Because it does not belong to our exponential family of distributions. If it does not belong to exponential family of distribution, then MVB estimator do not exist. It does not belong. Okay, I hope that it is correct. Option D is the correct option. Now moving towards another question. Question number 46. Here they have given us the method of movement. We have to calculate the method of movement and the distribution. If you see it properly, it is of gamma distribution. Now for method of movement, let us first see what is the formula. Again, I am telling you expectation of x should be equal to x bar. This is the formula. If x follows gamma distribution with parameters alpha and beta, then expectation of x is equals to alpha beta. But here, if we see that it follows gamma distribution with the parameters alpha and 1. So here the formula will be alpha into 1, which is alpha. So keeping it equal to x bar is the MOM, or method of moment estimator, is equals to x bar, which is our option number B. This was as easy as this, easiest question ever. Okay. Now moving forward towards question number 47. 47 is again a assumption of SPRT. In SPRT, we have been given three terms, n, alpha, beta. N is the sample size, we can say. Alpha is type 1 error and beta is type 2 error. Okay. Now since we have to find the SPRT, then to find the correct SPRT or sequential probability ratio test, we will in general term also, if I have to figure out something, then I will keep the errors constant and I will be figuring out n so that they decrease as much as it can. So n here is a random variable and these two are fixed constants. We have to fix the error in order to get the best result. So keeping the error fixed, here we all can see the option B is the correct option that matches our this theorem, where n is a random variable, alpha and beta are fixed constant. The most important property of SPRT. Now moving towards another question, which is question number 48. This is also an easy one and it is directly a theorem that has been asked. But let us do it in detail. Let me outline it. How will you do it? And you can solve it on your own and I will write the answer. What is it coming? So they have given us f x theta, which is 1 upon root 2 pi e raised to the power minus x minus theta upon 2 whole square. Now from here you can see that this is a normal distribution with mean theta and variance 1 that has been given to us. So first of all we will be calculating the likelihood of this. If we are calculating the likelihood of this, it will be 2 pi raised to the power n e raised to the power minus summation xi minus theta upon 2 whole square. Then the formula for calculating SPRT ratio is L1 upon L naught. L1 upon L naught will come here on theta 1 and theta naught. By taking this, we will be getting our final answer in the formula like it will be equal to e raised to the power minus 1 by 2 here it is not 2. Let us keep it 2 outside because 2 is not under square. Let us keep 2 outside. Okay. So 1 by 2 summation xi minus theta 1 whole square, or we can write n theta 1. Summation is all over this minus summation xi minus n theta naught whole square. And on solving this, now we all know that our value of a is greater than equal to 1 minus beta upon alpha. We all know this. A is equals to this and lambda n is greater than equal to a. So putting lambda n values here and putting the values of a here, we will be getting our final answer. Why have we taken a? Because they have given us 1 minus beta upon alpha. Because we are taking a because this is the upper limit, and upper limit should be considered while we are calculating for sequential probability ratio test where theta 1 is greater than theta naught. That is why we have considered a. On solving this, you will be getting option B as the correct option, taking log on both sides, and you will be getting a final answer for summation over xi is greater than equal to, you can take it m n whatever, they have taken it equal to m, I goes from 1 to m, so you can take it m, lambda m or n, whatever the case, it doesn't matter. So it will be theta 1 minus theta naught log of 1 minus beta upon alpha plus m theta naught plus theta 1 upon 2. Just consider the final answer, it contains m, and if you are calculating it with n, then it will be containing n. Okay, this is directly a theorem that has been asked. I have told you how to prove it. You can prove it on your own, and if you face any doubt in proving it, then we will be taking it in the next lecture on the board. Okay, now moving towards our question number 49, which is again statement based. So two statements again have been given to us. Let us see what are they. First statement is NP lemma gives a general method for testing simple H naught versus composite H naught. Yes, it is correct. When H naught is simple and H1 is composite, then we consider NP lemma. And hence equation 1 is the correct equation. Now if we are writing, sorry, NP lemma is considered when both the H naught and H1, the normal the null hypothesis and the composite hypothesis both are simple, then only we consider NP lemma. Otherwise, we do not. Exactly the same statement has been asked previously in this year's question paper only. We have solved it in board. You can see which question is that. You can comment down below which question is that, so that you can help your friends find out the question. Or you can also tell the series of that question number. And here it is NP lemma, so this statement is wrong because they have given us simple versus composite, which is wrong. But when we talk about the likelihood ratio, then it can be simple or composite versus simple or composite, anything can be taken, and hence this statement is correct. Then our final option will be option number B, which state that only second statement is the correct statement. Now moving forward towards question number 50, which is also the last question for the day. Question number 50 has given us for testing mu is equals to mu naught and mu is not equals to mu naught, 90% confidence interval for mu normal distribution. Now we all know that for normal distribution, it is symmetric. Normal distribution is symmetric in nature. So if I am taking the values, suppose this is the normal distribution, if I have the interval this and this, then our mean will be lying the center of this interval, mean will be x bar or mu, whatever you are taking. It will be lying between exactly between 360 and 400. And how to calculate this? It will be equal to x bar is equals to lower limit plus upper limit upon 2, which will be 760 upon 2, which is equals to 380. And hence our option number A is the correct option for this question. This is as simple as this. We have done it in previous year questions paper in our courses as well. If you have done it, then it was very easy for you. So that's it for today's lecture. I hope that you understood whatever we have done today in the class. If you still have any doubt in any question, you can ask us in the comment section and we'll be answering you. All the best. Thank you.